Have you ever pondered on how your computer stores and retrieves data with such speed? It's all thanks to a marvel of modern computing known as memory architecture. Essentially, memory architecture is the intricate system that organizes the different types of memory in your computer. This system is designed with one major goal in mind: to ensure that your computer's central processing unit, or CPU, can access data as quickly and efficiently as possible. Now, the memory hierarchy is like a well-oiled machine, with several levels each playing a crucial role. These levels include registers, the fastest and smallest form of memory; cache memory that temporarily stores frequently used instructions; random access memory or RAM; read-only memory or ROM; and long-term storage solutions like hard disk drives and solid-state drives. And let's not forget external storage solutions like USB drives. Ready to dive into the fascinating world of memory architecture? Buckle up! Starting at the top of the hierarchy, we have registers. These are the quickest and smallest form of memory, integrated directly into the CPU. Think of them as the computer's short-term memory, limited in size, usually only a few kilobytes. But what they lack in size, they make up for in speed. Their access time is lightning fast, which is crucial for their role. Registers hold the most frequently accessed data, storing intermediate data, program counters, and flags. They're the go-to place for the CPU when it needs data in a flash. So, while registers might not store your entire digital photo collection, they're vital for the smooth and efficient operation of your computer. Every time the CPU needs to perform a task or make a calculation, it's the registers that provide the necessary data at breakneck speed. Registers may be small, but they sure are mighty. Next in line, we have cache memory. Now, if you're thinking about your web browser cache, you're not entirely off track, but it's a bit more complex than that. Cache memory is a high-speed, volatile computer memory that acts as a buffer between the main memory and the central processing unit, or CPU. It's relatively quicker compared to random access memory, or RAM, but it's not as speedy as the registers we've talked about earlier. So why do we need cache memory? Well, think of it as the middle ground. It's larger than registers but smaller than RAM. It's like a high-speed shortcut for your CPU to access frequently used data and instructions. This means it's incredibly valuable to the smooth operation of your computer. Now, cache memory isn't just one uniform entity. It's divided into different levels, each with its own characteristics. We have level 1, or L1, which is the smallest but fastest. Then we have level 2, or L2, which is a bit slower but larger. And then level 3, or L3, which is even larger but also a tad slower. It's all about balancing speed and capacity. But wait, there's more. Cache memory is also split into instruction cache and data cache. As the names suggest, the instruction cache stores the instructions that your CPU will need to execute, while the data cache holds the data these instructions will operate on. So what's the catch with cache memory? Well, it's volatile, which means it doesn't retain data when the power is turned off. But that's not really a problem, as its main role is to provide quick access to frequently used data while your system is running, not to store data long term. In essence, cache memory is a crucial part of the memory hierarchy. It's the perfect intermediary, offering a balance between speed and size. It's like the middle child that often gets overlooked but plays a vital role in keeping the family, or in this case your computer system, running smoothly. Cache memory, the perfect middle ground between speed and size. Moving on, we come across the workhorse of computer memory, RAM. Random access memory, or RAM as it's more commonly known, serves as the temporary storage of data that the CPU and operating system can quickly read from and write to. It's like the computer's short-term memory, remembering what tasks the computer is actively working on. Let's talk about the characteristics of RAM. While it's slower than our previous contender cache memory, it's significantly larger in size. This size difference allows RAM to hold more data, but it also means that accessing that data takes a bit more time. However, it's important to note that this slowness is relative. In the grand scheme of things, RAM is still incredibly fast. Another important characteristic of RAM is its volatility. This means that the data stored in RAM is lost when power is turned off. But why would we want a memory that forgets everything each time we power down? Well, this volatility is actually a feature, not a flaw. It allows the computer to start each new session with a clean slate, free from any leftover data from previous tasks that could potentially slow down performance. Now, how is RAM used in a computer system? The primary role of RAM is to hold program instructions and data during active processing. When you launch a program or open a file, it's loaded from your hard drive into RAM. This is because RAM is much faster than your hard drive. By storing this data in RAM, your computer can access it much more quickly. So the more RAM your computer has, the more data it can hold for quick access, which generally makes your computer run faster and allows it to handle running multiple applications at once. So, to sum it up, RAM is the temporary storage hero of the computer world. It's the place where your computer keeps the data it needs to access quickly and frequently. It's a vital component that plays a significant role in your computer's speed and overall performance. RAM, the temporary storage hero of the computer world. Scene script. Next, we have a memory that never forgets, ROM. Dive into the world of read-only memory, or ROM for short. A unique type of memory, ROM is non-volatile, retaining its contents even when the power is turned off. Unlike RAM, which is like an artist's sketchpad, constantly changing and evolving, ROM is like a carved stone tablet, unchanging and permanent. In terms of speed, ROM typically offers slower access compared to RAM, but what it lacks in speed, it makes up for in resilience. It's used for storing firmware and essential system instructions. Think of it as the computer's genetic code, containing the fundamental instructions that tell the computer how to start up and operate. In essence, ROM contains the BIOS or UEFI firmware, along with other critical system instructions. It's the steadfast memory that holds the computer's most crucial information, ensuring it can function correctly from the moment you hit the power button. ROM, the resilient memory that always remembers. Now let's talk about the long-term storage giants, HDDs and SSDs. When it comes to storing data for the long haul, hard disk drives and solid-state drives are the heavyweights of the memory architecture. They are the non-volatile storage devices that keep our operating systems, applications, and personal data safe and sound even when the power is off. First, let's look at hard disk drives or HDDs. These are the granddaddies of storage, having been around since the 1950s. They work by storing data on magnetic platters, with a read-write head floating above to access or alter the data. One of the main characteristics of HDDs is their large storage capacity. You can store terabytes upon terabytes of data on a single HDD. However, their mechanical nature makes them slower than their solid-state counterparts. They also tend to be more prone to failure due to physical wear and tear. On the other hand, we have solid-state drives or SSDs. These are the new kids on the block, bringing a whole new level of speed and reliability to data storage. SSDs have no moving parts. Instead, they store data on interconnected flash memory chips. This design allows for much faster data access than HDDs, making your computer feel snappier and more responsive. SSDs also tend to be more durable and reliable than HDDs due to their lack of mechanical parts. However, this speed and reliability come at a cost, as SSDs are typically more expensive than HDDs for the same amount of storage. In a computer system, HDDs and SSDs serve the crucial role of long-term storage. They hold the operating system, which allows your computer to boot up and function, the applications that you use for work or play, and all your personal data. From your precious family photos to that massive spreadsheet you've been working on for weeks. In essence, HDDs and SSDs are the librarians of your computer system. They store, catalog, and fetch the data you need when you need it, all while keeping it safe when you don't. HDDs and SSDs, the reliable keepers of our data. Finally, we have the portable solutions. External HDDs and USB drives. These are storage devices you can physically connect to your computer, allowing you to expand your storage beyond the limits of your internal drives. The key characteristic here is portability. You can pack up terabytes of data, unplug the device, and take it with you wherever you go. External storage devices are generally slower compared to internal storage, but their convenience and versatility make up for it. They are fantastic tools for backing up important data, transferring files between different systems, or simply providing additional storage when your main drives are full. And here's a fun fact. Did you know that some external hard drives can store up to 10 terabytes of data? That's roughly equivalent to 2 million songs or 500 hours of high-definition video. External storage, offering portability and convenience in data storage. So, there you have it. The fascinating hierarchy of computer memory. We've journeyed through the layers of a computer system, starting with the ultra-fast registers embedded within the CPU, storing intermediate data and program counters. We then looked at the cache memory, a high-speed volatile storage solution that temporarily holds frequently accessed instructions and data. Moving on, we explored the workhorse of a computer system, the random access memory or RAM, which provides temporary storage for active processing. We also touched on the indomitable read-only memory, ROM, that retains essential system instructions even when the power is off. We then delved into the realms of long-term data storage with hard disk drives and solid-state drives. And finally, we talked about external storage options like external HDDs and USB drives, offering portable and removable storage solutions. Next time you're using your computer, you'll know a bit more about the incredible technology working behind the scenes.